CO2 is a major driver of human-induced climate change. To limit its impact, emissions must be reduced to an absolute minimum. While some industries have already started switching to CO2-free production, sectors such as cement, steel and chemicals still lack practical alternatives. To reach our climate goals, we need innovative technologies. One of these key technologies is carbon capture and storage, CCS for short. To make this possible, the COREu project is building a Europe-wide network. It is developing 4 strategic transport and storage routes in Greece, Czech Republic, Poland and Ukraine. In the Greek route, a large-scale pilot project is being implemented to further mature the route and to demonstrate and de-risk the technology. With CCS, CO2 is captured directly at the source. The goal is to store it long-term beneath deep rock layers. They act like a natural seal, preventing the CO2 from escaping back into the atmosphere. For this, safe transport and a carefully monitored storage process are essential. For transport, special high-pressure containers have been developed. They allow CO2 to be moved flexibly, safely and efficiently. From offshore platforms, the CO2 can then be injected into former oil and gas fields or aquifers. There, it is securely contained beneath the seabed in porous rock, sealed by a dense cap rock layer. This way, sites become safe and permanent storage facilities for CO2. Within the project, additional options are also being developed that allow CO2 to be injected directly from ships. This will make the process even simpler in the future. To minimize potential risks, several monitoring methods are being developed. An autonomous CO2 sniffing underwater vehicle detects leaks at an early stage. Such leaks can occur along pipelines or directly at the injection site. Seismic sensors record even the smallest earthquakes, both on land and underwater. This is important to ensure that stored CO2 remains securely contained and does not trigger unwanted seismic events. CO2 flow and composition monitoring ensures that there are no harmful side effects for people, nature, or the environment. With a solid databases, digital tools help identify tomorrow's risks today. They assess whether geological sites are suitable and how CO2 can be injected efficiently and safely under varying conditions. Analysis tools monitor and simulate pipeline stability, helping to minimize risks. To operate CCS efficiently and sustainably, CCS hubs will serve as shared infrastructure nodes, linking multiple emitters, transport routes and storage sites. This approach lowers costs, reduces risks and accelerates the development of a Europe-wide cross-border CCS infrastructure. But COREu is not just about technology. The project also works on the conditions needed for real-world deployment. Clear regulations, public acceptance and consistent environmental protection. Only with these in place can CCS be implemented safely and sustainably across Europe. Industry alliances in different regions promote knowledge sharing and accelerate the development of more hubs. Within the project, COREu is also developing new digital platforms. The COREu for Learn portal and the COREu Metaverse allow anyone to virtually explore CCS routes and storage sites. At the same time, COREu shows how Europe can already use technology today to cut CO2 emissions from hard-to-abate industries, safely and sustainably. Find out more at coreu.eu.